Hi guys, welcome to today's tutorial. Today we'll be treating on sequence and series. Alright, now by way of introduction, we'll be looking at objectives. Our objectives is to introduce sequence and series and highlight their relevance. Alright, now definition. A sequence is an ordered list of numbers following a specific pattern or rule. Now, an ordered list of numbers following a specific pattern or rule. That is to say, each sequence is being guided by a specific rule, or the numbers are following a specific pattern. Example, we have 1, 3, 5, 7. Now, if we look at those numbers, 1, 3, 5, 7, we can deduce that each and every of the subsequent numbers is increasing by 2. This is 1 plus 2 to give us 3, 3 plus 2 to give us 5, 5 plus 2 to give us 7, 7 plus 2 will give us our next number, okay, which will be 9, 9 plus 2 will give us our next number, which is 11, and so on and so forth. So the rule guiding this sequence is an addition of plus 2 to our subsequent numbers, okay? Now, each number in the sequence is called a term, okay? This is referred to as our first term, second term, third term, and so on. Now, each number is referred to as a term, all right? Now, the position of a term is important, or its order matters, okay? The position of each term is important in finding the rule guiding our sequence. Example, we have 2, 4, 6, 8, 10. Now, there are two types of sequence which we are most likely to have. We have the geometric sequence and the arithmetic sequence. Now, for the arithmetic sequence, we have the second term and the first term. In between the second term and first term, we have what we call the common difference for the arithmetic sequence. And the common difference is established by subtracting the first term from the second term, or the second term from the third term. Now, for example, we have 2, 4, 6, 8, 10. All right. Now, in this, our first term is 2, our second term is 4, our third term is 6. So for us to find our common difference, we are having it as T2, which is the second term, minus the first term, T1, or T3 minus T2, or T4 minus T5. So whichever way, T2 is 4, minus 2 would give us 2. T3 is 6, minus T2, which is 4, would give us 2. T4, which is 8, minus T3, which is 6, would give us 2. So in this, we can see that our common difference is constant all through, which would be, our common difference here would be 2, all right? That's why we have it as in an arithmetic sequence, the common difference is 2. While when we talk about our geometric sequence deals with common ratio. And in order to find our common ratio, we are having it as T2 divided by T1, okay? Now, in the ratio we have there, in the geometric sequence we have there, we have it as 1, 2, 4, 8, 16. Where 1 is our first term, 2 is our second term, 4 is our third term, 8 is our fourth term. Now, if we have our common ratio as T2 over T1, or T3 over T2, or T4 over T3. Now, T2 is 2 over 1, and our T3 is 4/2, and our T4 is 8/4. Now, in all this, we will see we are having a 2. So our common ratio would give us a 2. Now, series, on the other hand, is the sum of terms of a sequence. Now, when we talk about series, we look at adding up the number of terms in a sequence. Okay? Now, example, we have in a sequence, we have 1, 3, 5, 8. Now, when we talk about, 1, 3, 5, 7, when we talk about the series of this sequence, is simply 1 plus 3 plus 5 plus 7. Okay? When you add up the terms of a sequence together, you form a series. Now, example, we have from the sequence of 2, 4, 6, 8, the corresponding series will be the addition of these numbers, 2 plus 4 plus 6 plus 8, which will give us 20. And when we look at from the sequence of 1, 2, 4, and 8, which is a geometric sequence, the series will give us 1 plus 3 plus 4 plus 8, which gives us 15. Now, talking about types of sequence and series, our objective here is to explore the types of sequence and learn how to find their terms. All right, now the first we'll be looking at will be arithmetic sequence or arithmetic progression. In some textbooks, you'll see it as arithmetic sequence. In some other textbooks, you'll see it as arithmetic progressions. Now, we've earlier defined that a sequence is numbers that follow a particular pattern or rule. Now, here we are looking at as arithmetic sequence as a sequence where each term after the first term is obtained by adding a constant difference, which is referred to as D. Now, remember, when we had 1, 3, 5, 7 as our sequence, okay? Now, following what we've said here, where each term is defined by adding a constant D, now our first term here is 1. So if we add plus 2 to 1, we get the next term, which is 3. If we add plus 2 to 3, we get our next term, which is 5. If we add plus 2 to 5, we get our next term, which is 7. So the constant difference being added here would be 2. Okay? Now the general formula for finding arithmetic sequence is a subscript n, which which will give us a plus n minus 1 d. Now, where a is our first term, n is number of terms, and d is our common difference. Okay? A is our first term, n is our number of terms, and d is our common difference. Now, for example, if we want to find the 10th term of this series, that would become A10 will become A. Our first common difference, our first term here is 1 plus n, which is 10, minus 1 times our common difference, which is 2. So this becomes 1 plus 9 times 2, which will be 9 times 2 will give us 1 plus 18, which gives us 19. That means our 10th term in this sequence would be 19. All right, now let's look at an example here. If we have 2, 5, 8, and 11, we have a sequence as 2, 5, 8, and 11. Now, in such a sequence, you should first of all, what would be your first term? Now, your first term for every sequence is the first number that the sequence begins with. So here our A, which is our first term, would be 2. And now the common difference, for us to find our common difference, we are doing T2 minus T1. This is T2, T1, T3, T4. Okay, so either we do T2 minus T1 or T3 minus T2 or T4 minus T3. So either ways you get same common difference. So having this, we are having this as 5 minus 2, which gives us 3. Okay, 5 minus 2 will give us 3. So our common difference for this series would be, for this sequence would be 3. Now, it says find the 15th term. Now, looking for the 15th term of this sequence, that means we are having T15 equals A plus n minus 1 times D, where our A in this sequence is 2 plus n is 15 minus 1 times 3, which is a common difference. So this gives us 2 plus 14 times 3. Now 14 times 3, 4 times 3 will give us 12. Write down 2, carry 1. 3 times 1, 3 plus 1, 4. So this gives us 42 plus 2 will give us 44. So our 15th term for this series, for this sequence, will be 44. Now, looking at the sum of terms for an arithmetic progression, okay, for our sum of terms for an arithmetic progression, this is used for calculating for finding the terms when given. Now, this is the general formula for arithmetic progression. General formula for arithmetic progression. Now, for sum of terms in an AP, we are having it as Sn equals n over 2 brackets 2a plus n minus 1 d. All right, or we can use Sn equals n over 2 brackets a plus l. Now, where our a is our first term and n is number of terms and our l is last term and d is common difference. Okay, our n is our number of terms, a is our first term, l is our last term, and d is our common difference. At times, you might be given just the first term and the last term of your series of your sequence for you to find the sum of terms. So you should be able to know which formula to apply in finding your sum of terms. But in the case or situation you're given the number of terms, you use your first formula, and in situations when you're given your last term, you use your second formula. Find the 10th term of the sequence. Now, our sequence, we have 3, 7, 11, and 15. Now, if we look at this sequence, what's our A, which is our first term? Our first term from this sequence is the first number on our sequence, which is 3. Now, we look for the common difference. Now, if you're looking for the common difference of this sequence, these are T1, T2, T3, T4. Now, we can use T3 minus T2 to find the common difference. Now, this will be 11 minus 7. 11 minus 7 will give us 4. That means our common difference for this sequence is 4. 3 plus 4 will give us 7. 7 plus 4 will give us 11. 11 plus 4 will give us 15. All right. Now, looking at this, we know that our T10, 10th term, our T10 would be A. Okay, let's write our general formula first. Our Tn will be A plus n minus 1 D. Now, this is the general formula for finding our number of our terms for an AP. So our T10 would now be A, which is 3 plus 10 minus 1 times 4. Okay, this will give us 3 plus 9 times 4. Now 9 times 4 would give us 36. This will be 3 plus 36, which gives us 39. So the 10th term of this series, of this sequence, would be 39. And if we say we want to find the sum of the first 10 terms, let's say we have to find the sum of the first 10 terms using our formula Sn over 2 brackets 2a plus n minus 1 d. Okay, now we are looking for the sum of the first 10 terms. Now this will become 10 over 2 brackets 2. Our first term here is 3 plus 10 minus 1 times 4. Okay, now this will give us 5 times 3 times 2, 6, plus 9 times 4. Now 9 times 4 will give us 36. This will be 5 bracket 6 plus 36. And 6 plus 36 will give us 42. So this becomes 5 times 42. Now 42 times 5 will give us 5 times 2, 10, write down 0, carry 1. 2 times 5, 4 times 5, 20 plus 1, 21. So our sum of first 10 terms for this series would be 210. All right, now we've looked at arithmetic progression and how to calculate to find the terms and the sum of terms. Next, we'll be looking at a geometric sequence or geometric progression. Now, a sequence in which a geometric progression or sequence is a sequence in which each term after the first is obtained by multiplying the previous term by a constant which is referred to as a common ratio. All right. Earlier on, we looked at how to find a common ratio as a T1 as a T2 divided by T1. Now, for a geometric sequence, our general formula would be AN equals AR n minus 1, where our A is our first term, R is our common ratio, and N is our number of terms. Okay, where A is our first term, R is our common ratio, and N is our number of terms. So to find the sum of the first number of terms, if R is not equal to 1, now if our common ratio is not 1, now we'll be using the formula sum of terms equals A bracket R is power n minus 1 all over R minus 1. Okay, as long as our common ratio is not 1, we'll be using this formula to find the sum of the first number of terms. So looking at our sum to infinity, if R is less than 1, we'll be using the formula S equals A over 1 minus R, where our A is our first term and R is our common ratio. Now let's look at examples. Now if we have 3, 6, 12, and 24 as a sequence, okay, if we have 3, 6, 12, and 24, now our first term here is 3, so we call that T1, T2, T3, T4. Now our first term would be 3. Now for us to find our common ratio R, we are having it as T2 over T1 or T3 over T2 or T4 over T3. Now, either ways, we should be having same answer. So T2 over T1 will be 6 over 3, which will give us 2. 12 divided by 6 will give us 2. And 24 divided by 12 will give us 2. So our common ratio would be 2. Okay, now it says find the 7th term. Now if we want to find our 7th term, which is T7, we have it as using our formula. Okay, let's start with our formula. Tn equals ARn minus 1. Now, in this situation, our T7, our n is 7, which is the 7th term we are looking for. A is 3 times r, which is 2, raised to power 7 minus 1. So this gives us T7 equals 3 times 2 raised to power 6. Now 2 raised to power 6 would give us 64. So this becomes 3 times 64, which will give us 3 times 4, 12, write down 2, carry 1, 3 times 6, 18, plus 1, 19, which will give us 192 as our 7th term. Now, the next example says, find the sum of the first 5 terms of this sequence. Now, if we are looking for the sum of the first 5 terms of our sequence, we have 2, 6, 18, and 54. Now, this is T1, T2, T3, T4. So our first term here would be 2, okay? And our common ratio would be T2 over T1, which will give us 6 over 2, which will give us 3. So our common ratio here is 3. So if we use our general term, Tn equals ARn minus 1, our T5, which is our 5th term, would be A, which is 2, times R, which is 3, raised to power 5 minus 1. So T5 would be 2 times 3 raised to power 4. So 2 times 3 raised to power 4 will give us a T5, which we are having as 3 times 3 times 3 times 3, 81, 2 times 81, which gives us 162. So our 5th term will be 162. Now, our question says, find the sum of the first 5 terms. Now, we're going to find our sum of first 5 terms. Okay, our sum of first 5 terms would be, either we do 2 plus 6 plus 18 plus 54 plus 62, 162 to get a sum, or we can use a formula that says Sn equals A bracket Rn minus 1 all over R minus 1. Okay, where our A would be 2 brackets, our R is what? 3 raised to power 5 minus 1 all over our R, which is 3 minus 1. So this gives us 2 brackets 3 raised to power 5 All right, so let's add this up to see if we have 162 plus 54 plus 18 plus 6 plus 2, we are having it as 242. So we can see either ways we have our answer as 242. Now, The next type of sequence we'll be looking at is harmonic sequence. Now, by definition, this is a type of sequence where the reciprocal of the terms form an arithmetic sequence. So, if we have an arithmetic progression, okay, and we turn the arithmetic progression into its reciprocal, then we have a harmonic sequence. For example, where we have 2, 5, 8, 11. All right. Now, in this sequence, we're having it as an arithmetic progression, which is an addition of +3 to each and every of our terms. So, for it to be a harmonic sequence, we'll have the reciprocal of each and every of this number to be 1/2, 1/5, 1/8, and 1/11. Now, this forms a harmonic sequence. Now, it's important to note that this is less common for basic courses, but useful for advanced application. Okay. Now, another type of sequence to also know is our forbearance sequence, where we have each of the terms is the sum of the next two previous terms. Okay, so our first term here is 1, the next term is 1, so 1 plus 1 will form our next term, 2 plus 1 will form the next term, 3 plus 2 will form the next term, 5 plus 3 will form our next term, and so on and so forth. Okay, it is the recursive sequence, a recursive sequence where each term is the sum of the two preceding terms. And the general formula for it is Fn equals Fn minus 1 plus Fn minus 1 plus Fn minus 2. Okay, so this forms a general formula for our sequence. Now, it says in this sequence where we have 1, 2, 3, 5, 8, 11, 5, 8, 13, all right, and so on, that we should find the 8th forbearance number. Now, for us to find the 8th number, we have to label this as a T1, T2, T3, T4, T5, T6, and T7. So for T8, we are having it as T6 plus T7. Since from our definition is the addition of the two preceding numbers. So T6 here is 8 plus 13, which gives us 21. So the next term in this sequence would be 21. Now, talking about quadratic sequence is gotten from our formula an equals n raised to power 2, okay, where our n is a number of terms. So if we have a1, this becomes 1 raised to power 2, which is 1. a2 will become 2 raised to power 2, which gives us 4. And a3 becomes 3 raised to power 3, which gives us 9, and so on and so forth. Okay, now let's look at some work examples. Now, the first example there deals with AP, and it says find the sum of the first 20 terms of a sequence. Now, if we look at our formula for finding AP, we have the first term for finding the number of terms as Cn equals a plus n minus 1 d. Okay, this is for finding our terms, and since we asked for the sum of the first 20 terms, will give us n over 2 bracket 2a plus n minus 1 d. Now, with this, we use this in finding our sum of terms. Now, since we're looking for the sum of the first 20 terms, our n will be what? 20. And our sequence is, we have 5, 8, 11, 14, and so on. So our first term, A, would be 5. And our common difference, D, okay, our common difference, D, will be 8 minus 5, which will give us 3. Now, having our numbers, we can impute into this to find the sum of our first 20 tens. This gives us 20 over 2 Sn equals 20 over 2 bracket 2 bracket 5 plus 20 minus 1. D is 3. Okay, so this will give us 10 bracket 10 plus 19 times 3. Now 19 times 3 would give us 57. 10 bracket 10 plus 57. Okay, so this will give us 10 times 67, which gives us 670. So the sum of the first 20 terms of this sequence would be 670. All right, now the next question on GP says find the sum to infinity of, we have 12, 8, and 16 over 3. All right, now our common ratio here, our first term here, A, is 12, and our common ratio here will be 8 divided by 12, which gives us 4 here, 2, 4 here, 3, which gives us 2 over 3. Okay, and we know that our sum to infinity is A over 1 minus R. Okay, so from here, imputing our A, we have it as A, which is 12, all over 1 minus 2 over 3. Now we have this as 12 over 1 divided by, working on this, we'll have it as 1 over 3. Now, how did we get 1 over 3? We have 1 over 1 minus 2 over 3. LCM will be 3. 1 into 3, 3 times 1, 3 minus 2, which gives us 1 over 3. So that's how we arrived at this. So having this, we have this as 12 over 1 times 3 over 1, which gives us 36. So the sum to infinity of this sequence would be 36. So if we have 2, 4, 6 as an AP, we are asked to find its harmonic sequence. Now, which from our earlier discussion, we said it's the reciprocal of our arithmetic progression. So the harmonic sequence of this will become 1 over 2, 1 over 4, and 1 over 6, and so on and so forth. Okay, now this is just a recap of all we've done before. Now we've talked about series and how to calculate its sum of terms. All right, now we have the finite series, and for the arithmetic series, those are the formula for calculating the sum of terms in our arithmetic series. Okay, now for the geometric series, we have this, where we have our geometric series as Sn equals 1 minus r raised power n all over 1 minus r, for where your r is not equal to 1. Okay, and we have an example there for you to go through, where we are asked to find the fourth term, the sum of the first 4 terms of this series. Okay, now we have our S4 equals 5, which is our first term, by 1 minus r raised power, since it's 5, our terms are 5, that will be, our terms are 4, that will be r raised power 4, which is our r is 2 raised power 4, divided by 1 minus 2. Okay, so when we divide through, this will give us 1 minus 16, which gives us minus 15. Minus cancelling minus will leave us with 15. So 5 times 15 would give us 75. Okay, would give us 75. That's how we arrived at this answer. Now, for the geometric series, now if it's a convergence series where r is less than 1, okay, our sum to infinity would be A divided by 1 minus r. Okay, since our r is less than 1. But if it's divergent where our r is greater than 1, we'll simply add up our terms together. Now, still on our recap, we said earlier that sequence is a list of numbers in a particular order, while our series is the sum of terms of our sequence. Now, the important things to take away here is always to remember that your sequence works or deals with an ordered list of numbers that follow a particular or a certain rule, while series is the sum of our sequence. Now, geometric progression deals with a constant ratio. Arithmetic progression deals with a constant difference, while harmonic progression is the reciprocal of our arithmetic progressions. Now, these are all powerful tools for solving real-life problems. Now, it can be used in finance for calculating loan repayments or investment growth. It can be used in physics for modeling motions or energy, and in nature, like the forbearance for plant structures. Okay. Also in computer science for algorithm and data processing. Okay. Also for economics and business to find compound interest, saving plans, and loan repayments. Engineering and science for population growth modeling, radioactive decay and wave patterns, and the mathematics for progressions, summations, and infinite series, and also in calculus calculations. Alright guys, with this, we've come to the end of today's tutorial. Ensure you stick by as we'll be having some practical questions on what we've just learned.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Cacao,